Hey everybody, welcome back to another fun and exciting Algebra 1 video. In today's class, we're going to continue in chapter number 3. This is lesson number 3, and we're going to be talking about slope. Slope of a line. What is slope? Slope is kind of the idea of the incline of the line. Think about like on a playground, maybe on a slide. The steeper the slide, the faster you're going to go down it, right? Maybe if you're sledding on a hill or on a roller coaster, whatever it is, the steeper the hill that you're on, the faster you're going to go. So, you're talking about going from, if you're going straight up and down, then you're going to go down really fast. But then if the slope is a little bit less, it's going to take you a lot longer to get down that hill if you're sledding or whatever it is. So the steeper, the faster. So that's the idea of slope. The steeper the slope of the hill, the faster you're going to go down the hill. Well, in graphing, there is a way to figure out what the slope is. There's actually a number that we assign to the slope to tell us how steep that slope potentially is. Go ahead and open up your books and look at page number 91. On page number 91, the incline or the steepness of a line on the Cartesian plane is called the slope. There's two different types of slope. Well, actually, there's four, but the first two that we'll talk about is positive slope and negative slope. Okay, positive slope is a slope that goes from, do you remember, and I think it was the last lesson, maybe it was 2 lessons ago, I talked about the Cartesian plane having quadrants. So this quadrant here was the positive positive. And one thing I said in that lesson was if the line basically goes into that quadrant, actually I guess it would be this way, if it goes up into that quadrant, then that is going to be a positive slope. Also, if it goes down into quadrant number 3, that is a positive slope. So this line going up and to the right and down and to the left, this is a negative quadrant here, this quadrant number 3. So 2 negatives in algebra makes a positive, so this is a positive slope line. This is the second one here is a negative slope line, okay, because it's going up into the left and down into the right. So this, if it's kind of ending, it doesn't really end, it goes on forever. That's what this little arrow means. But if it goes into that quadrant to the upper left, then it is going to be a negative slope. And if it goes down into the quadrant on the down right, which is quadrant number 4, it's also going to be negative slope. This is really important to know. So up to the right, it is going to be a positive slope. Up to the left, it is going to be a negative slope. I told you there's actually 4 types of slope, so the other 2 would be zero slope. Zero slope means that it's flat, okay? And think of it as like a slide that didn't have any incline to it, right? Zero slope. There's zero incline. You're not going anywhere on that slide. That you're just going to get on it and sit there, okay? So that has zero slope. You don't move at all. Okay. The other one is a slide that's straight up and down. Okay. I don't want to go on that slide. That's not a ride for me. Okay. I do love roller coasters and things like that, but I need to be strapped in and there needs to be something at the bottom that's going to catch me. So, this is undefined. I don't think any of you want to get on that slide that's just straight down and then boom, you hit the bottom. So that is what we call an undefined slope. And I'm going to tell you why it's undefined here in just a little bit, but just kind of bear with me and just know that that would be an undefined slope. All right, how do we find the slope? How do we find this number? The slope of the line is found by comparing any 2 points on the line. Notice, any 2 points. It doesn't matter if it's way up and to the left, if it's way down to the right. It doesn't matter where you find your points. Any 2 points on the line, you can compare them. The way that we compare them is by using this slope formula right here. M, and the easy, well, I don't know that there's an easy way, but you have to remember that M equals slope. In algebra, whenever you see the letter M, we very rarely use M as a variable in algebra. So whenever you see M, especially the M that kind of looks like it's in italics, just like this little M right here, that's always going to mean slope. Okay, so it's talking about slope. And then it says rise over run. Let me switch over here to my computer and we'll just go over here. So here's our formula. M equals rise over run. Now you're like, rise over run, what does that mean? What does rise mean? So you could go like up and down. That's rise. And then run is left and right. I'll put another equal sign here. So the slope, so let me write over here, slope equals M. Okay, so it's important to remember that. Slope equals rise over run. Slope equals up and down over left and right. And then there's another way that we can write this, and you could write it using the triangle, and I'll tell you what that means in a second, but triangle y over triangle x, okay? If you'll notice going back and looking in your book, on page 91, you'll see down here it says that the symbol triangle, it's called a delta. So in the Greek alphabet, you have different letters, alpha, beta, okay? So the A and the B is called alpha, and then the B would be called beta. The D is called delta in the Greek alphabet. And so this is what the delta looks like. The delta letter, if you will, in the Greek alphabet looks like a triangle. So we use the D, delta. The triangle means change in. So the symbol triangle represents the change of something. So we're going to say the change in y, right here, over the change in x. So if we go back over here, there's one more way to write this. This is all the same thing. Slope equals m equals rise over run equals up and down over left and right equals the change of y over the change of x. The last way to write this, and this is kind of in the formula mode, and this is the way that you'll be able to figure it out, to solve it, is we put the y, and you can do y1 or y2. The formula says y2 minus y1 over, and so this is going to be this is going to be your change of. So that's that delta. The change in the 2 points of y over the change in the 2 points of x. So you would have your x2 minus your x1. And so this would be the formula for finding slope. So if you ever have points, you can plug them into this formula and it will give you the slope of the line. So let's say our 2 points, let me change the color here so you can see it a little bit better. So on the bottom of page 91 in your book, it gives us an example, and we can go ahead and plug these values in. So it says our first point is going to be at 2, negative 1. And so we can call this point 1. This is our first point that they give us. And then point 2, and that looks like p plus 2, but it's not. It's point 2. And our point 2 is going to be 4, 3. And this again is on the bottom of page 91. They're just giving us this information. This would be like we graphed it and there's a line on that graph. And they're saying one point is at 2, 1, 2, negative 1, and the other point is at 4, 3. Okay? So remember that when we're doing coordinate points, this is going to be the x and this is going to be the y. Notice that this is point number 1, so this is going to be our x1, this is going to be our y1. Over here, we're going to have our x2 and our y2. Okay? And so now we just kind of plug everything in back to the original equation. So what is our y2? Well, it's over here. So our y2 is going to be 3 minus our y1. What's our y1? It's right here. And it's not just 1, it's negative 1. Be very careful that you take your negative 1. So negative 1. And I put that in parentheses so that I don't have just like negative, negative. So that way we can tell what we're doing. Put that in parentheses and we're going to actually add that or subtract that in just a second. And then we have x2, which is 4 minus. Where am I getting this minus sign? I'm getting it from the formula. Okay. So I know this doesn't have a minus sign on it, but my formula has a minus sign. So my next thing is going to be my x1, which is 2. All right, now I can go ahead and do my math. So 3 minus 1. You have to go back to your rules of addition and subtraction of positive and negative numbers. The way that we do that is we would change the sign of the second and add. Okay, that's an easy problem now. 3 plus 1 equals 4 over 4 minus 2 is 2. Now you have to reduce this fraction. This is not your answer. We have to reduce it. How do we reduce that? Well, in this case, we would reduce it down and we would get 2 over 1, or 2 over 1 equals 2. We don't have to put the over 1. You can, but you don't need it. So there we go. Our slope in this case, our m equals 2. A lot of times your slope is going to be a fraction, but in this case, we did not get a fraction. We got a whole number, and that's fine if your slope equals a whole number. All right, let's quick look back here at the book, and on page number 92, you're going to see this 3.3 example here, and we have points at -2, 5 and 2, -1. Now, I'm going to show you kind of a little bit different technique to doing it. So I've kind of got it mapped out here. It's not perfect, but you get it. There's a point here, and that is at, that's our -2, 5. So we went 1, 2, negative, 1, 2, 3, 4, 5 positive, and that's where we got that point. And then the other point, again, is at 2, 1. So 1, 2 positive, and then 1 negative. Now, remember what our formula was. Our change in y over our change in x, okay? So if we go to our graph here, where we put it on our paper or it's in your book, if we count the number of spaces between these 2 points, we will actually solve the problem. There's more than one way to do this. So if I do the change in y, that's like saying the change between this point and this point. Okay, so what is my change between those 2 points? Well, we can just count. Now notice we're going down. Okay, now you could say I'm going to start here and I'm going to go up. That's fine too. I'll actually show you that where you get the same answer. So if we go down 1, 2, 3, 4, 5, 6, and that puts us at this spot right here. So we went down 6. So our change in y is going to be 6 over what's our change in x? Well, now we're going from this point here to this point here. Okay, so we're saying how many times did we go over? So again, if we started from this point, we have to stay, this is now our starting point. If we start there, we have to keep using that point. I can't skip back over to this point and then start counting from there. Again, I'll show you how to do it, but you can't just switch halfway through. We have to say, okay, this is our point 1, and this is our point 2. Okay, so if you try to flip it in between in the middle of the problem, you're going to get the wrong answer. So here we go. We're going from point 1, 1, 2, 3, 4 spots. And then that puts us here on this point. So that answer would be 4. Okay, so we'll put a 4 here. But before you write your answer, this is really important. So we went 4 spots, and notice we went 4 spots to the right, right? So we went 4 spots, 1, 2, 3, 4, and we came over here. So that's whenever you're going to the right, you're going in a positive direction. So let's assign the signs to this. So this 4 is actually going to be a positive 4. Now look, we went down when we did our y. So because we went down, this sign on the y is a -6. You have to be careful to put your signs on these. If you don't put your signs on them, you will get them wrong. So now we're going to go ahead and we're going to reduce this, and this is going to give us a -3 over 2. Our slope, our m, equals -3 over 2. All right. Now, I told you that I could also do it going the other way. Watch this. If I start at this one, if I say, okay, this is my point 1, that's fine. We're just going to go up 1, 2, 3, 4, 5, 6. So there's our, now we're going up 6 though. And so now this one you have a +6, okay? And then, but just wait, be patient with this. And since we started here, we have to go over 1, 2, 3, 4. So we're going to the left this time, so that's negative. So now our denominator is negative. Our negative is on the 4. Notice how over here I put my negative just in the middle of it. Like I didn't assign it to the top. I just put it right here in the middle. Our slope is this still reduces to negative 3 over 2. So it doesn't matter which way you go, you're going to get the same answer. Now let me show you that with using the formula to solve that. Okay, so we'll go back down here. Here's our formula. And so we're going to use that formula to try to solve this again. So let's do the same thing, but this time we're going to use our formula. What were our points? Our points were the negative 2, 5. That's we'll call that point 1. It doesn't matter what you call it. We'll call it point 1. Our other point was 2, 1. And so this will be our point 2. And now we're going to plug it into this formula right here. So our y1, which one's our y? Well, our x is the first one. Our y is the second one. And you might want to write this on every one so that you can remember right at first. I forgot to add a minus sign here, so we'll add that. That's on our second point, was 2, -1. So sorry about that. And so we'll go back in here and we'll start adding into our formula. So what's our formula? We'd go back up here, y2 minus y1. So what's y2? y2 is right here. That's -1 minus y1, which is 5, over x2, which is 2, minus, that's part of the formula, that minus is in there. So we have to put that, and then our x1 is -2. So -2, we put that in parentheses. So here on the top, we would get, if we have -1 and we're subtracting 5, we change the sign of the second and add. So -1 plus -5 gives us -6. Over, here we do the same, change the sign of the second and add, and that's over 4. We've had this before. What did we do? We reduced it and we got 3 over 2, and that is a negative slope. So the same thing that we did up here, when we counted it out and we had the change in y over the change in x, we counted it out on the graph, we got the same answer when we did it mathematically here using the formula. You can do it either way you want. All right, let's jump back over here to the book real quick and we'll finish up. So now they say, what if we give you a slope and a point? You should be able to graph a line with those two things. So let's take a look at it here in your book on page number 93. You'll see that they give us a point, and our point is -1, 3, right here, -1, 3, and our slope is -4, okay? So let's go back down here to our display, and we are going to put these onto the graph paper here. So our point is -1, 3. So let's go ahead and put that on there. So -1. So we're going to the left. So if we always start at 0, right? So -1, and then we're going up 3. So we went backwards, and now we're going up 1, 2, 3. So that's where our point's going to be right here. Okay. So there's our -1, 3 point. Okay. Now what they say is they want you to draw a line. Well, what other information do I have? I have this -4 over here. Remember that what is slope? So another way to write slope is m equals the change in y over the change in x. Well, what is the x and the y here? Well, in this case, we would have remember, we want it in a fraction, but we don't have a fraction here. So we would just put it over 1. That makes a fraction out of this. So in other words, we're going to go up. When we go back over here to this graph here, we're going to go -4. That's on the y. Our change is -4. So what does that look like? -4 means we're going down 4. So 1, 2, 3, 4. So that's where we are. And then we're going to change 1 to the right because it's a +1. So then we're just going to come right back over here to this main line, and that's where our point's going to go right here. Okay. And then you can now draw your line right here because you know what your point was and you know what your slope is. Okay. So um, again, lots of stuff going on, right? It's like sometimes your mind is just like, oh my goodness, like there's so much going on there. If you will take the time and learn your formulas here, I think that you're going to find great success in this because you're just going to be able to plug in. Or if you'll kind of try to wrap your mind around, like, okay, what's really going on here? Well, what's going on here is that we have a change in the y. The y is the up and down. If it's positive, we change up. If it's negative, we change down. All right. And then you have the same thing with your left and right. If it's negative, you're going to the left. If it's positive, you're going to the right. And once you figure that out, it's not really that difficult. Get your point on there, work on your changes left and right, up and down, whatever, and then you should be able to get your line from that. That's all I've got for you. Hope you learned something there. If not, make sure to go back, slide it back, watch it again, and then just try these. You're only going to be able to do these once you start actually attempting them. So make an effort, give it a try, and I think that you'll find out that you can do it pretty easily. We'll see you later. Have a good one. Bye bye.